Hello everyone, welcome to Easy Electronics. Yes, I will say that if you like my videos, then please like, subscribe and share my channel. And this is the educational purpose channel. I know that there are no kind of music or no entertainment thing, but yes, the channel is made only for the educational purpose. And if you see all the videos, then that will obviously and 100% it will give you the advantage related with your subject knowledge and for understanding the concepts related with the electronic subject. Now we are into the series of the objective questions for the semester 1 of F.Y.B.Sc Computer Science electronic subject. Here we are discussing the first paper, Semiconductor Devices and Basic Electronic Systems. We had already discussed the first and second unit in the two videos of this whole series. Today I am going to discuss about the questions, objective questions of the third unit, that is Mosfet, metal oxide semiconductor, field effect, transistor. And again we will have a series of three videos for fourth, fifth and sixth unit respectively. These are the topics which are discussed in this unit. If you want to go through these topics, then the link is already given. Please click on that link and you will get the whole playlist for this particular unit. Now the very first question is, when the gate voltage is VGS is negative, the mode of operation of MOSFET is known as. Now VGS is actually the voltage which is applied between the gate and source terminal of the MOSFET. Okay, so there are two types of voltage that we can apply to the MOSFET. If we are applying negative voltage, then the MOSFET is working in the depletion mode, and if this voltage is given in the positive mode, then the MOSFET is operating like the enhancement mode MOSFET. Now here VGS is negative, so that's why option C is correct option, depletion mode. And when we are applying the polarity of VGS like this, okay, then this becomes the depletion type of MOSFET. Okay, this is the polarity for n channel depletion type MOSFET. In MOSFET, role of silicon dioxide is, so here this is the construction of n channel D MOSFET. Here we are using the SiO2 layer between that of the negative channel, n channel, which is having the negative electrons, and the gate, which is having the positive charge on it. Okay, so for separation of these two plates, we are having the SiO2 layer between them, and actually it is acting like the dielectric medium between these two plates of the structure, which is actually working like the capacitor structure, looking like the capacitor structure. Here are the two opposite charge plates and which are separated by the SiO2 layer. So that's why the SiO2 layer is acting like the dielectric medium between these two. An n-channel DMOSFET with a positive VGS is operating in. So here it is operating in the enhancement mode. VGS, if we are applying positive VGS, then that is the enhancement mode of the MOSFET, and this is how we can apply the plus VGS. This is the polarity of the voltage applied between the gate to source voltage. This is for the n-channel enhancement MOSFET. The smallest gate voltage at which the induced channel is formed so that a current can flow in the drain source circuit is called as, so this voltage is actually called as the threshold voltage, and here we can see it. And actually after crossing this voltage only we will get the channel between the two drain and source terminal. The channel is actually formed, and as the channel is formed, so that's why the current can flow from source to drain because of this channel only. So this channel is formed only after this voltage. And that's why the definition of the threshold voltage is the smallest gate voltage at which the induced channel is formed, and so that the current can flow in the drain to source circuit. So this voltage is called as the threshold voltage. MOSFET are mostly used as, these are some of the option, and MOSFET mostly they are used as the switching circuit. This is the circuit diagram for MOSFET working like the switch. So when the current is flowing through the circuit, then we can say that it is in the on state, and when the current is not flowing, then the MOSFET is in the off state. MOSFET is a bipolar, unipolar, tripolar device, or none of the above. So we know that the current in the MOSFET is only because of the majority charge carriers, and that's why we can call it as the unipolar device. Option B is the correct one. Now the input impedance of MOSFET is, it is actually in mega ohms, which we can say that it is very high. So that's why option A is correct. MOSFET consumes dash power. So actually MOSFET requires very less power for its working. Option C is the correct option here. This question is already discussed. When VGS is positive, then the mode of the operation of MOSFET is enhancement mode. Operation of MOSFET depends on, so as I told you, as it is called as the unipolar device, and because the current is flowing only because of one type of charge carriers, which are actually the majority charge carriers. So that's why it is called as unipolar device, and we can say that the operation of MOSFET depends only on the majority charge carriers. The drain characteristic of MOSFET is also called as transfer input output characteristic, or none of the above. So the drain characteristic is plotted between the drain current and drain voltage, and both of them are the output quantities, and that's why this characteristic is called as the output characteristic. This is how the characteristic looks like. On the x-axis we are plotting the VDS, which is the drain to source voltage, and on the y-axis we are having the drain current in milliampere. We are plotting the graphs for various VGS values, and this is how the drain characteristic of n-channel enhancement MOSFET looks like. Okay, so drain characteristic is also called as the output characteristic of MOSFET. The transfer characteristic of MOSFET is plotted between. Now the transfer characteristic is always plotted between that of the input and output quantities. Okay, here it is plotted between the input voltage VGS and output current ID. Okay, so that's why the correct answer is option B, between that of the output current ID and input voltage VGS. And this is how the transfer curve of MOSFET looks like. Now some of the symbols are given here, and we just have to tell that which is the enhancement MOSFET symbol. So the correct symbol is this one. Okay, while drawing the symbol of fate, there is a lot of confusion between the lot of confusion faced by any student. So that's why I will suggest to just do a little practice of drawing the symbols of each and every field effect transistor, so that you will be 100% sure that this is the a J junction field effect transistor symbol, this is the depletion fate symbol, and this is the enhancement fate symbols. So the correct option is this one. Okay, actually the enhancement MOSFET is having this dotted line. So this is how you can actually differentiate between the symbols. Yes, so this was all about the third unit, objective questions related with the metal oxide semiconductor field effect transistor. And we will meet in the next video, in which we are going to discuss about the power supply, objective questions related with unit 4. And if you like this video, then please like and subscribe my channel. Thank you so much.
इसके बाद